Okay guys, so what we're going to start looking at today is the actual sum of a geometric series. Now we're doing a partial sum because we're doing it up to a particular value, so the 5th value or the 10th term or something like that. Later on we will look at which series we can add to infinity. But for the moment we just need the partial sum formula. So you'll see here that there are two different versions. They're both the same, but what we find is that the first version is quite useful when your ratio is between -1 and 1. So the absolute value of r is less than 1, or r is between -1 and 1. So when you get a fraction or a decimal, you use the first version, a outside of 1 minus r to the n, all over 1 minus r. If your ratio is greater than 1 or less than -1, so if the values are getting larger each time, then you want to use the second version. Okay, so we're going to go through one of each here. The first exercise we've got, or the first example we have, we've got the series 2 plus 8 plus 32, and continues on like that. So what you can see is a, your first term for this one is equal to 2, and r, remember we find that by doing term 2 divided by term 1. So 8 divided by 2 is 4. So what's happening is we're multiplying by 4 every time. The terms of our series are getting larger each time. We want to use the second version of that formula. Okay, so Sn equals a outside of r to the power of n minus 1 all over r minus 1. Okay, so then when you substitute in, you're going to get a 2 outside of 4 to the power of 10 minus 1 all over 4 minus 1. Now this can go straight into your calculator and give you your answer. It's going to be big. Alright, so this is equal to 699,050. Why is that getting so big? Well, we're multiplying by 4 every time. Those terms are going to get very, very large. Okay, and if you're not sure, try putting it into the calculator. Start with 2 and multiply it by 4. See what you end up with. Okay, then when we add them all together, we get this really large number. In the second one, let's have a look at what we've got. So our a, our first term for this one is 20, but what's our r? Now remember, it's what we're multiplying by. So we are multiplying by 10 over 20. We're multiplying by a half. So r is equal to a half. And they want the first 5 terms, so n is equal to 5. Okay, so because r is less than 1, the absolute value of r is less than 1, then what we're going to do is use the first formula. So Sn equals a outside of 1 minus r to the n all over 1 minus r. Okay, so just straight substitution in. So the sum of the first 5 terms is equal to 20 multiplied by 1 minus a half to the power of 5 all over 1 minus a half. Now again, you can do this in your calculator, but you will find some of them don't work well on the calculator because it ends up giving you this horrific decimal. And remember that when we do decimals, we're often rounding off if it's something that continues on. If it's an irrational number, the decimal is an approximation. This one does work out okay on the calculator though. If it doesn't, you may have to go back to your index laws. So there it is, 38.75. Okay, there's not a lot of examples for this one, guys, because it's really that simple. You're just substituting into one of those two formulas with some of the variations that we've been looking at so far. That's what you need for the next exercise. Good luck, and I'll see you in class.